All right, so let's dive into large language models, or LLMs.
LLMs.
Yeah, you know those things. You've probably heard of ChatGPT, right?
Yeah,
It seems like LLMs are like everywhere these days,
definitely.
changing how we write and code, even create art. It's wild.
Yeah.
We're going to use this deep dive to unpack how LLMs actually work, going beyond just the buzzwords,
Right.
and get into the mechanics. And we'll be using the article, Understand How LLMs Work, a quick and intuitive guide as our jumping off point for this deep dive.
Well, it's interesting because LLMs, they operate so differently than the traditional software that we all used to.
Yeah.
Instead of being given like a set of rules to follow, they learn from huge, massive amounts of data,
Oh,
identifying all the patterns in human language.
so it's less like programming a computer and more like teaching a kid a language by just having them listen to conversations and read books.
Yeah, like total immersion.
Right.
That's a good way to think about it.
Yeah.
And this difference is huge because it allows LLMs to be creative in a way that rule-based systems just can't. Yeah. They can adapt to new situations and come up with completely new outputs, which is really what makes them so powerful.
It's really amazing. Now, how do they actually pull this off?
Yeah.
This can't be pure magic, right? There's got to be some serious tech behind it.
It's not magic, but it is pretty ingenious.
Okay.
LLMs use what's called a transformer model.
Transformer.
Yeah.
Okay.
Imagine like trying to understand a whole sentence, but you're only reading one word at a time.
Okay.
You totally miss the connections and the overall meaning, right?
Right.
Transformers, on the other hand, can process a whole chunk of text all at once,
Oh.
understanding how all the words relate to each other simultaneously.
That's a big step up from processing one word at a time.
Yeah.
But how does the model, figure out which words are the most important in a sentence? There's so many nuances to language.
Right. Well, that's where self-attention comes into play.
Self-attention.
Yeah.
Okay.
This is a mechanism that allows the model to focus on the most relevant words for the context. So, for example, in the sentence, time flies like an arrow.
Okay.
Self-attention helps the LLM figure out that flies refers to the passage of time, not the insects.
Gotcha.
And it does this by analyzing the relationships between all the words flies, time, and arrow, using mathematical representations called vectors.
So it's not just looking up words in a dictionary. It's actually doing a mini analysis of the entire sentence.
Exactly.
Wow.
And then to add another layer of sophistication,
Okay.
there's also multi-head attention.
Multi-head attention.
Imagine instead of just one spotlight focusing on those important words, you have several spotlights,
Okay.
each highlighting different aspects of the sentence.
So it's like having different experts analyze the same text.
Yeah.
One might be focused on grammar, another on the relationships between words, and yet another on the overall theme.
That's a great analogy. Each head focuses on a different linguistic feature,
Okay.
and then they combine all their insights to create a much richer understanding, kind of like a panel discussion on a book.
Like a panel discussion? I like that. All right, this is definitely making things clear. But all this analysis must require some serious training for the LLM, right?
Source.
It's not like they just magically appear with all this knowledge.
Absolutely. The training process is crucial.
Okay.
LLMs are trained on an enormous amount of text data.
Like, how much are we talking here?
I mean, think books, websites, code, you name it. Anything you can imagine.
Wow.
And this exposure allows them to learn patterns in language, almost like a child, learning by listening to stories and conversations.
It's like force-feeding the LLM with all the information it could possibly need.
Pretty much.
Is there a method to this madness?
Well, there are two key tasks involved in this pre-training phase.
Pre-training.
Yeah. The first is called masked language modeling.
Masked language modeling.
It's kind of like a word game where the LLM has to fill in the blanks.
Okay.
So, for example, if you give it the sentence, the cat sat on the fence, it can predict that the missing word is mat.
So it's learning to anticipate the next word based on the surrounding context. That's clever. What's the second task?
The second task is called next sentence prediction,
Next sentence prediction.
where the LLM learns which sentences logically follow each other. It's like figuring out the flow of a conversation or a story. For instance, it can determine that the sentence, I love pizza, would likely be followed by, it's my favorite food, but not by, the car is blue.
It's amazing how these models can pick up on these subtle connections in language.
It is.
But all this learning raises a question. What about inaccuracies in the data they're trained on? Do they just accept everything as fact?
That's a really crucial point. LLMs can sometimes generate outputs that reflect the biases or inaccuracies that are present in their training data.
Okay.
It's like if you only learned about the world from a single source,
Right.
your understanding might be a little skewed.
That makes a lot of sense.
Oh,
So while LLMs are incredibly powerful, we can't treat them as like infallible oracles.
right.
We need to be aware of their limitations and use them responsibly.
Exactly. And that's where things get even more interesting. We haven't even touched on hallucinations when an LLM just makes stuff up.
They just make stuff up.
Yeah, or the fact that they can give completely different answers to the exact same question.
Oh, wow.
But I think we should save that for part 2 of our deep dive.
Okay, sounds good. Take a break and we'll come back and tackle those topics.
So those hallucinations we were talking about,
Yeah.
it's kind of unnerving to think an AI can just make stuff up, you
It
know?
really is. It makes you wonder if these LLMs are so advanced, why do they sometimes like invent facts?
Well, it comes down to the fact that LLMs are at their core incredibly sophisticated pattern recognition machines.
Okay.
They're amazing at completing patterns, but sometimes they get a little too enthusiastic and fill in the blanks incorrectly,
hmm
especially when dealing with information that wasn't part of their training data.
So it's like they're trying to force a puzzle piece where it doesn't belong.
Yeah.
They're using the patterns they know to make sense of new information, even if it leads to like a made-up result.
That's a great way to put it.
Yeah.
The article actually gives an example of a customer service chatbot
Okay.
that's been trained on general company policies,
Uh-huh.
but not on a specific nuanced policy.
Okay.
So if a customer asks about that specific policy, the chatbot might try to answer based on its general knowledge, even if that leads to incorrect information.
It's like the chatbot is saying, well, based on what I know about company policies, this seems like the most logical answer, even though I've never actually encountered this specific situation before.
Exactly.
That makes sense.
Fine.
But what about those instances where an LLM gives different answers to the same question? Is it just being unpredictable?
It's not entirely random, although it can seem that way.
Okay.
Even with efforts to make LLMs completely deterministic,
Uh-huh.
there are still factors that can cause variations in their outputs.
Interesting.
It all kind of boils down to the fact that these models run on very complex hardware and software.
So there's more to it than just the LLM thinking differently each time.
Absolutely. For instance, tiny differences in how computers perform calculations can accumulate over millions of operations,
Okay.
resulting in slightly different outcomes.
So even the smallest variations can cascade into larger discrepancies.
Right.
That's pretty mind-boggling.
It is. And then there's also the aspect of parallel processing.
Parallel processing.
Modern LLMs run on multiple processors all at the same time.
Huh?
And the order in which those processors complete their tasks can influence the final output.
So it's like having a team of chefs working on the same recipe, but each chef might add ingredients in a slightly different order,
Right.
leading to subtle variations in the final dish.
Exactly. And then on top of that, there are software quirks and implementation details that can also contribute to variations in outputs.
Gotcha.
It's a very complex system with many moving parts, and that complexity can sometimes lead to unpredictable results.
So we've got these incredibly powerful LLMs that are learning from massive amounts of data, but they can hallucinate, be influenced by data biases, and their outputs can be somewhat unpredictable. It's a lot to take in.
It is, but there's still more to explore.
Okay.
Let's shift gears a bit and talk about how LLMs actually process language.
Okay.
Because they don't actually see words the way we do.
Really?
They break down text into smaller units called tokens.
Tokens. Are we talking about like those little plastic chips you get at an arcade?
Not quite, but the concept is similar.
Good.
In this context, tokens can be words, parts of words, punctuation marks, even special characters.
Yeah.
It's like deconstructing language into its fundamental building blocks, much like Lego bricks.
Okay.
For example, the word unstoppable might be broken down into the tokens un, stop, and able.
It sounds like the LM is reading a sentence in code rather than plain English.
Yeah, I could say that.
Does this tokenization serve a specific purpose?
It's crucial for a few reasons. First, it helps LLMs handle unknown words. If they encounter a word they've never seen before,
Right.
they can try to break it down into smaller, more familiar tokens.
So it's a strategy for dealing with the unknown, like solving a puzzle by working with smaller pieces.
Exactly. Second, tokenization makes it easier for LLMs to recognize patterns.
Okay.
By breaking down words into their component parts, they can identify recurring patterns that might not be as obvious at the word level.
So they're not just seeing the surface of the language, they're looking at the underlying structure, like the grammar and syntax.
Precisely. And finally, tokenization increases computational efficiency.
Okay.
By working with smaller units of language, LLMs can process information faster and use less memory.
Tokenization, another piece of the puzzle, falls into place. Is there anything else we need to know about how these LLMs work on the inside?
There's one more critical concept to understand,
Okay.
the context window.
Context window.
It refers to the amount of text an LLM can process at any given time.
So it's like trying to read a book through a tiny window.
Mm.
You can only see a small section of the text at once.
That's an excellent analogy. As the LLM processes more and more text, that window slides along.
Okay.
And older information might get forgotten or compressed to make room for new information.
It sounds like LLMs have a limited short-term memory.
Yeah,
They can only juggle so much information at a time.
exactly. And this limitation can lead to some interesting consequences. For example, if you ask an LLM a question that requires it to recall information from earlier in the conversation,
Uh-huh.
it might struggle if that information has already slipped out of its context window.
That explains why LLMs sometimes seem to lose track of what you were just discussing. It's like they have a mental reset button.
It's certainly one of their quirks. But it's important to remember that these limitations stem from the fact that LLMs are still a relatively young technology.
Yeah.
They're incredibly powerful, but we're still learning about their capabilities and their limitations.
It's like we've stumbled upon a hidden door leading to this fascinating world of AI, but we're still figuring out how to navigate the rooms and unlock its full potential. I think we need to take a step back and ask, what does all of this mean? We've learned so much about how LLMs work, but what are the implications?
That's the crucial question, isn't it? I think the key takeaway is that while LLMs are revolutionizing the way we interact with technology, it's vital to understand how they work in order to use them effectively and responsibly.
Okay.
They're not magic and they're not human. They're powerful pattern recognition systems, but they're still machines.
So we need to be mindful of their limitations, aware of the potential for biases, and always critical of the information they provide.
Absolutely. We can't treat LLMs as infallible oracles. We need to approach them with a healthy dose of skepticism and use our own judgment and critical thinking skills to evaluate the information they give us. And that leads us to some even bigger questions. What happens when these LLMs become even more advanced? How will they shape our world, our creativity, our understanding of intelligence itself? But that's a conversation for the final part of our deep dive.
So welcome back to our deep dive into the world of large language models. We've explored the technical inner workings of LLMs, like their transformer architecture, self-attention, tokenization, and even their quirks like hallucinations and the limitations of their context window. But now let's shift our focus and explore the bigger picture.
Yeah, I think what's so fascinating about LLMs is they're not just changing how we use technology.
Right.
They're also prompting us to ask some pretty profound questions about ourselves and what it means to be human in an age of increasingly sophisticated AI.
That sounds pretty deep. What kind of questions are we talking about here?
Well, consider this. LLMs, they learn from the data we create. The books we write, the articles, we publish the code, we develop, even the conversations we have online.
Right.
It all becomes part of their training data.
Wow.
So in a sense, they're like mirrors reflecting back the patterns of our own thoughts,
Yeah.
our creativity, and yes, even our imperfections.
So they're holding up a mirror to humanity, showing us who we are, warts and all.
That's a great way to put it. And this reflection raises some really thought-provoking questions.
Yeah.
For example, if an LLM generates text that is offensive or reflects harmful biases,
What?
does that mean the AI is inherently flawed? Or is it simply mirroring the biases that already exist within our society?
That's a tough one. It's like blaming a parrot for repeating a bad word it's heard.
Right.
The parrot isn't at fault, it's just mimicking what it's been exposed to.
Exactly. And that's where the responsibility lies with us as the creators and curators of the data that shapes these LLMs. We need to be more aware of the biases we might be inadvertently perpetuating through the information we create and share online.
So it's not just about building better AI, it's about creating a better world for AI to learn from.
Precisely. It's about fostering a more just equitable and inclusive society, both online and offline. The values we embed in our digital world will ultimately shape the values of the AI systems that inhabit it.
This conversation has definitely taken a philosophical turn. But it's important to consider these broader implications. We can't just embrace AI without thinking critically about the potential consequences.
I completely agree. And it's not just about ethics and biases.
Right.
There's also the question of creativity.
Okay.
We've seen LLMs generate incredible works of art, music, and literature. But does that mean they are truly creative? Or are they simply remixing existing patterns in novel ways?
That's a question that has puzzled philosophers and artists for centuries. What does it mean to be creative? And can machines truly possess that ability?
There's no easy answer, but I think it's safe to say that LLMs are pushing the boundaries of what we thought was possible for machines. They're challenging us to rethink our very definitions of creativity and intelligence.
That's pretty exciting, even if it's a bit unsettling at times. It feels like we're on the cusp of a new era.
Absolutely. It's a time of incredible innovation and discovery, and who knows what amazing new possibilities will emerge as we continue to explore the potential of AI.
Well said. I think we've given our listeners a lot to ponder today.
I hope so.
We've gone from the technical nuts and bolts of how LLMs work to the philosophical implications of AI for humanity. It's been quite the journey.
It has, and I hope it sparked a curiosity in our listeners to continue exploring this fascinating field. There's so much more to learn and discover.
Absolutely. Keep those minds curious, folks. And remember, as we navigate this brave new world of AI, it's more important than ever to stay informed, stay engaged, and keep asking those tough questions. Thanks for joining us on this deep dive into the world of LLMs.